Had I been thinking about this difference in these coordinates a little bit more carefully, I would have realized that at some point, which is right here, -40, this difference has to be 0. Because at very high temperatures, so this is boiling water, 100 degrees Celsius, 200 degrees Fahrenheit. At very high temperatures and then moving to cooler temperatures. So this was the hottest temperature recorded on Earth. This was part A. This is freezing water, 0 degrees Celsius, 32 degrees Fahrenheit. I would have realized that this difference is getting smaller. It's getting less as you move to cooler temperatures. And this is part C, where we calculated that point is -40, and then it goes beyond part B. It's a -8 and 8/9 degrees difference, and the coldest temperature recorded on the planet, 38 and 8/10 degrees negative at the coldest point on the planet. So if you look at that on a graph, so here are all those coordinates once again. Here they all are graphed on this graph of Fahrenheit is equal to 9/5 degrees Celsius plus 32 degrees. And if I add to this the graph that has a slope of 1 and that goes through 0, so where Fahrenheit is equal to Celsius, they intersect at this -40 right here. So what's happening is if you look at the difference in the y-intercepts, that's 32 degrees, and look at the difference in the slope, that gap closes and eventually intersects at -40, -40. And so the difference in the slope is this 5/5. So I'm going to take this 1 degree Celsius and rewrite it as 5/5 degrees Celsius and subtract the 9/5 from that. So that's the difference in the slopes. It's a -4/5. And so what that means is that this gap between these two graphs is closing at a -4/5 degrees Fahrenheit for every degree Celsius. So if I have 32 degrees Fahrenheit difference, how many degrees Celsius is it going to take for that gap to close? Well, it's closing at a -4/5 degree every time, starting out with a difference in the y-intercepts of 32 degrees. So how many of these 4/5 can you get out of 32 degrees? That's 32 divided by -4/5, and you can calculate that as 32 times a -5/4. I have more to say about that in a moment. And you end up that they intersect at -40 degrees right here. And this is the algebra that we did. We took the degrees Celsius, set it equal to the expression for Fahrenheit is equal to this expression. Fahrenheit is also equal to degrees Celsius when they intersect. This right here, I'm going to rewrite this as 5/5 degrees Celsius. I'm going to add a -9/5 degrees Celsius to each side. So this goes away on this side. You're left with 32. Calculate -4/5 degrees Celsius. Multiply by the multiplicative inverse. The reason that you do that is you need to figure out how many fifths there are total. So there are 160 fifths. 5 times 32 is 160. And you're going to divide those 160 fifths by 4, which is 4/5 every time. And so how many of these groups of 4 can you get out of 160? That answer is 40. And it's actually a -40 in this problem. So here are these 32 units. I'm going to divide these 32 units into fifths. I'm going to take out 4/5 every time. So these are the 4/5 because I'm dividing this 32 by 4/5. So how many of these 4/5 can I get out? Well, I know I can get out 32 4/5 because there's 32 of these, and I'm left with this 1/5. So how many 1/5 are there? Well, there are 32 4/5, and that means that there has to be 32 1/5 remaining. So if I collect all of those 1/5 together, and I'm going to now divide those 32 1/5 divided by 4/5. So how many 4/5 can I get out of 32 fifths? So I have 32 fifths. I've lined them all up. and I'm going to take out 4/5 at a time. So how many of these 4/5 can I get out? Well, I have 32 of these things called fifths, and I'm going to divide that 32 fifths by 4 of these same things called fifths. Well, that's just 32 divided by 4. This 32 divided by this 4 is equal to 8. So now I have 8 4/5, and I already had 32 4/5. And so combined, how many total 4/5 are there? There are 40 of them. So I have 32 degrees. I'm going to divide this by 4/5. Every time I take out a 4/5, that is 1 degree. It's 1 degree more that I'm moving to the left. I can do that 40 times. So here's the algebra. We set these two expressions equal to each other, added a -9/5 Celsius to each side. Combine this. This is a -4/5. This is the difference in the slopes. This is the difference in the y-intercepts, because it starts at 0. Figure out how many total fifths there are. That's 5 times 32, which is 160, and divide that by 4. That's the 4/5 every time, and you get out 40 of them. In this case, it's a -40.